Hi guys, hope you're well. In this video we are going to work with application of calculus, which is optimization, especially for those of you who are preparing for prelim. It's very important to review your past papers so that you get familiar with different types of questions, right? So if you're new to this channel, what are you waiting for? Let's do the right thing. Let's subscribe. You only subscribe once. Thank you in advance. Right. So this question was taken from June examination, Gauteng province, mathematics paper 1, grade 12. Right. So the first question says, determine an expression for the rate of change of temperature with time. Okay. So let's start with reading the statement first. During an experiment, the temperature T in degrees Celsius varies with time in hours. According to the formula, T of T is equals to 30 plus 4T minus 4T minus half T squared, and TE, it's this is okay. This is its domain, okay, or the restriction, 0 and 10, right? So we need to find an expression. To find an expression, guys, to find an expression, it's not that difficult. Since they said determine expression for the rate of change, the rate of change is always going to be the first derivative. Let's start with 8.1. So we are going to say the derivative of t. Okay, what is the derivative of 30? That's 0. Derivative of 40, that will be 4. Why? Because here we use the power rule. Remember that your exponent here was 1. 1 times 4, that would be 4. And t minus 1 minus 1, it's 0. T to the power of 0, it's 1. Then 1 times 4, it will be left with 4. So similar thing, we're going to use a power rule. We're going to say negative half multiplied by 2. What are we having there? So when we use a negative half multiplied by 2, we get, so when we say negative half multiplied by 2, we get definitely we'll get minus 1. So that minus 1, okay, that minus 1 times t is going to be t. Then remember that this power, you subtract it by 1. 2 minus 1, that's going to be 1, and t to the power of 1, it's t. So actually we derive, guys, when they talk about the rate of change. The rate of change, it will be your first derivative. So you're going to derive this. We are going to get the derivative of t is equals to 4 minus t. So that's the expression. 2 marks for that. Then let's go to the other question, which is the other question, guys. It's 4 marks, right? So they said, during which time interval was the temperature decreasing? Mind you, they're not talking about the rate of change. They're not talking about this formula. They said, during which time was the temperature decreasing? So it meaning that they're talking about this formula where it's decreasing. Okay, we know where it's decreasing, it will be 30 plus 40 minus half t squared. It's less than, remember it's decreasing, so it will be less than 0 in this case. So can you factorize this? Nah, it won't be factorized, but the simplest way it will be to use a quadratic formula. So we will say t is equals to negative b plus or minus b squared minus 4ac divided by 2a. So let's go. Let's plug in let's plug 4 as our b. So remember that this is your a, and this is your b, and this is your c in this case. So 4 will be, so it's gonna be negative 4 plus then it's gonna be 4 squared minus our a will be negative half. So when we are here, our a, it's gonna be, okay, we said negative half. Our c, that will be 30, okay, divided by 2a. That is our a where our a it's negative half. So from there you punch your calculator. We are going to have two solutions. One must be positive, the other one must be negative. So let's punch our calculator there. So it's gonna be 4 plus it's gonna be negative 4 plus roots negative it's gonna be 4 squared. Okay, following our formula, as well as for AC, remember that where there's A, you put your negative half, and where there is C, you put 13, divided by 2, multiplied by negative half. From there, we get T as negative 4,72. Or, let's check. Now punch it when it's minus, then it's going to be negative 4 minus root 4 squared minus 4, our 8 minus half, then our C, that's going to be positive 30. So that's going to be 2a, 2a, it's going to be negative half. Okay. Right, so we are going to get 12,772. So they said during which time was the interval temperature decreasing. So between these two times our temperature was decreasing. Between t, when t is less than negative 4,72, or when t is greater than 12,72. So this is where our this is the time interval that we are going to have. So since they talk about the time interval, you can use critical values, guys. You can also use the table of signs to verify your answers, right? So where we are going to place negative 4,72 the side, and here going to place 12,72. So for here we are going to look at the other value that follows, that is after negative 4, that will be negative 5. When you plug it here, to show that it's decreasing, let's plug negative 5 in the equation. When we plug negative 5 here, we can see we get a negative value. Plug negative 5 in your original equation, plug it here. You can see that you are going to get a negative value. So here we're going to plug a value that is in between negative 472 and 12,72. Let's say if we plug maybe 7, what are we